Hello Python programmers, this is AK. In this video we are going to see about how to encrypt and decrypt the voice data. This idea comes from when I am sending the voice message to friends in WhatsApp. Actually I am very curious about how they are encrypting the voice data and how it looks like after the encryption process is done. Take an example, when you encrypt the text message, it actually looks like something we don't understand. It looks like some combinations of alphabets and numericals like that. There are so many encryption algorithms are available to encrypt the text form of data. In this video, we are going to check how the voice encrypted data looks like, and it is possible to encrypt the voice data using Python, and if possible, how it will be decrypted. So these are the questions that are rolling around in my mind. Before starting this video, do like, share, comment and subscribe. These things will motivate me to produce more good contents in Python programming. Okay, so let's start this video. Now come to the requirements. This program needs only two important requirements, that are cryptography library and Jupyter Notebook. The cryptography is an encryption and decryption library in Python, and we can use this library to encrypt and decrypt the data. This program is a key-based encryption technique. That means this program will generate a random key. We are using that key value to encrypt and decrypt the data. In cryptography, there is a rule called public key and private key. Public key is sender will encrypt the data with a specific key and the receiver will decrypt the data with another specific key. They are using two keys for encryption and decryption. This process is called public key cryptography. And next one is the private key cryptography. The private key is used to both encrypt and decrypt the data. This key is shared between the sender and the receiver of the encrypted sensitive information. The private key is also called symmetric. It is common for both parties. Private key cryptography is faster than public key cryptography because in the private key cryptography we are using one key for performing encrypt and decrypt operation. But in the public key cryptography, we are using two keys for encrypt and decrypt the data. Okay, so in this program we are going to use the private key cryptography to encrypt and decrypt the voice messages. Now the installation part. For this program you need to install two things on your system, that are cryptography library and Jupyter Notebook. Open your CMD and type pip install cryptography to install the cryptography library. And next one is optional. You can run this program on any IDE, but Jupyter Notebook is easy for me to explain this project in a stepwise manner. So only I am using the Jupyter Notebook, and it is optional to install this library. So after installing all the requirements, open your Jupyter Notebook and you need to import the libraries. From the cryptography library, you need to import the Fernet module. Let me explain how this Fernet module works in this project. The Fernet module is used to generate private key for us. This generated key is used to encrypt and decrypt the voice data. In this program, if you are encrypting the data, you need to pass the Fernet key, and for the decryption, you have to use the same Fernet key. Okay, so this is the usage of the Fernet module in this project. After importing the library, you need to generate the private key. So create a variable called key, and in this variable you have to type fernet.generate key. This instance is used to generate the random private key. When you run this part multiple times, it will generate a different number of keys. I will show you how it will work. You can see that it generates different private keys when I run this program multiple times. Now we are going to start the encryption process. Create a variable called fernet, and in this variable you need to pass your private key value. So type fernet, and inside this object you need to pass the key variable, and next we are going to store this key value in a separate file. First I type the code and then I will explain to you. Basically this statement is used to create a separate file called key, and key is the file which actually holds our original key value. Let me show you this file. Now you can see that in my index page it created a file that is named as key. When you open it, you can see our original key value. Using this file we are going to do the encryption process. Okay, before moving to the next process, I want to explain one thing to you, because if any beginner who watches this video, you may ask me these questions like, what is WB? So let me explain this more clearly. WB means you are writing something in your file, and for the read operation you have to use RB instead of WB. So these commands must be needed when we are doing the file handling operation using Python. And next we are going to read the file and store the data in the separate variable. Just copy the previous step and change the write operation into read operation. And below that, create a new variable called key, and in this variable you need to type file key.read. So this will help you to read the key file that we created. Now we have to insert our audio file. Just copy the previous step and here change your file name. I inserted my audio which is in the extension of Wave. This program will work on all audio formats. Okay, so you can use any audio formats for encryption and decryption. Now create a variable called original audio, and in this variable you have to read the data that is present in the audio file. Once we done this process, we are going to encrypt the voice data. Create a variable called encrypted, and in this variable you need to type fernet.encrypt and pass the variable original audio in this object. This step is very important in this program. Actually in this step you are encrypting the data with the private key value. Okay. Next we are going to create a separate file called voice encryption, and in this file we are writing our encrypted voice data. Here I am saving this file as a WAV format, so it will stay as an audio file after we finish the encryption process. Now you can see that our program created a separate file called voice encryption. If you want to see how the voice encrypted data looks like, then click the file. You can see that it won't play the audio when it is in the encrypted form. If you want to play this file, you have to decrypt the audio file. So let's start the decryption process. Decryption is same as the encryption. First I type the code and then I will explain to you. Now look at the decryption code. First we created our fernet variable which actually holds our private key. Private key is common for both encryption and decryption. And next we did the read operation of the encrypted voice file, and we stored that file data in the variable encrypted. And then we created a variable decrypted. It is used to decrypt the voice data using the private key. Final step is we are writing the decrypted data in a new voice file that is named as voice decryption. That's all about the code, and let's run this program. In this video we are going to learn about how to create a pattern to detect the face of people. Here the frame, and if you want to capture the video from, okay, and the else condition is it will break the loop when we press the Q button. Simply it closes the application after we detected the vehicles in the video frame. And finally call all the. You can see that it correctly plays the audio. So we did the decryption process successfully. And one more thing that I want to share with you, that is in this program we used the pre-recorded audio file and we successfully did the encryption and decryption on that. Actually we can do it by recording the live audio. You can try it by yourself and comment down your output. And that's all about this video. If you like this video, give a like and subscribe and share for more interesting updates in Python. Thanks for watching and thank you. See you on next video.